Hi, we are Group 1. Today we're going to talk about the problem of airline chatbots. I am Guodan Lin. Firstly, let's talk about the difference between MongoDB and MySQL. For the MongoDB, its document database is more flexible, and it supports rich querying and aggregation operations. And for MySQL, it's a relational database that uses a tabular structure and is more suitable for traditional vertical scaling. And let's move to the question 11. And what are the common complaints of each airline and type of traveler? List the top 5 common issues. And our approach is to create a keyword set and count word frequency. And our assumption first is the reviews must be genuine and valid. And our second assumption is the recommendation represents the overall evaluation of the flight by passengers. So among these, the feedback from non-recommending passengers is an important reference for airlines to identify complaints. So our step 1 is to filter valid data. Filter out the values marked as true in verified, and data with a value no in the recommended. The step 2 is manually select keywords. There are 2 columns, one is title and one is reviews. We have 2 people read the title and review and extracting relevant keywords, and each person selects 15 words, and among these 30 words, we finally select the keyword set as follow. And our step 3 is to establish the complaints categories. And we use the manually keyword we collected. And firstly, fill out the data with verify as true in the airline reviews table and recommended as no in the airline reviews table. And then we created categories of complaints based on our word clusters and categorized them using the keyword in the clusters for different types of complaints. And the following picture is how we achieve this step in MySQL. And this picture shows how we do this in NoSQL. Just use the sage service upgrade as examples. And step 4 is grade the complaints by airline and type of traveler and calculate their complaint count. The following 2 pictures shows how we achieve this step in MySQL and NoSQL.
Okay, I'm Liu Jingfeng, and I will introduce the remind part of question 11. For the step 5, we will rank the complaint count of the different groups, and the pictures on the slide shows how we do it in the MySQL and in the NoSQL. And step 6 is we get the final ranking result and use your code shows on the slides in the MySQL and in the NoSQL. And we got the final results, which is showing the table. From this table, we can observe that from the same airline, the complaints of the different types of passengers are similar, but there are also some differences that, for example, in Qatar Airways, the complaints business travelers and family are more concerned about the delay. And all of the types of the traveler reviews may issued related to the seat, while the family travelers in Qatar Airline are more focused on service issues. And in the Singapore Airlines complaints, business traveler complaints most in the service and the couple leisure traveler complain most in the seat. When comparing different passengers types, it is notable that business traveler have more baggage related complaints compared to the leisure travelers, which could be due to the business-oriented travelers have a higher demand of this. This suggests that the airline should do more related to it, like recommended the insurance for these travelers. Through the further combination analysis, additional insight can be derived and to help the airlines to do better and better understand the needs of the customers. For our approach's limitation, there will be three parts of it. The first is that the losing records related to the using of the keywords. It says passengers with the overall rating of recommended yes may also include some negative comments, and the overall negative reviews may still praise certain aspects in the reviews, making the word frequency statistics more complex. And the second limitation is the limitation of using the keywords identify the complaints. It is that language description are complex. If a type of issue is described without mentioning in the keywords, it will be missed in the statistics. And the third part is the interference of the using of the keywords to identify the complaints. It is the keywords for, it's just like the keywords for issue B mentioned while we're discussing in the issue A, but not in the complaint about the issue B, may also interfere with the statistics and leading to the inquiries.
Let's move on to question 12, and it's about using two data sets, infer the potential type of travelers for the complaints and the causes of complaints. So after our discussion, we think about three approaches, and we may explain the three approaches of question 12. And my name is Yan Yi. I will introduce the first approach. So let's just look at the two data sets. We may simply find that they have the same collection, which called root. And will this be ideal and the most ideal approach? We may think that we could merge the two data sets by using root collections. And here are our assumptions. We think that this approach may be ideal based on these two assumptions. The first is both datasets conclude the root dataset, so we can assume that this could be regarded as the common key to merge the two databases, therefore to reflect the general patterns. And the second assumption is that since the datasets are different airlines and time periods, we must assume that customer behaviors, complaint, and preference are similar across airlines on same route. But we simply find the difficulties, which is the route formats differ between the two datasets. In airlines reviews, the route formats are from the city names. For example, Seoul to Sydney via Singapore, but in customer booking, there are simply IATA formats. For example, ICNSYD. And our approach is to creating a map table to map city names to their corresponding IATA codes, therefore to normalize the route column for further analysis. So the step one we took is to find a mapping table after serving a lot of websites, and we find an existing data set from this mapping data website. And this is the data set of IATA codes and city names in CSV format. Then we use MySQL to subtract city A and city B, and then export them to external Excel file to matching data. We think that IATA might be more standardized format for route, and therefore our considerations is to convert city names to IATA codes. So we use the subtract city names to match the IATA codes in the mapping file, and soon we find difficulties, because they are extremely inconsistency in formatting as shown here. So there are a lot of unmatched entries that must be manual checked and input. This costs a lot of time. And then we combine the IATA codes of departure city and arrival city. We got the combined IATA code to match and merge the two datasets. But the result is far from ideal because we only got fewer than 10 fully matched samples, and this shows the poor logical relation between the two datasets. Therefore, this approach failed. And our major takeaways from this approach is that logical relation and data quality is very important in analyzing data, because if there's a lot of inconsistency for missing data or biased data, we could not convert a very reliable analyzed result. And it is also important to use the strength of each data analysis tool. For example, I used MySQL and Excel in this sample.
My name is Song Xunyi, and I'm gonna introduce our second approach that is merged by length of stay and number of passengers. So when we look at these two data sets, we found that in the customer booking table, there are two collections named as length of stay and number of passengers. So we think that we can give new definitions to the table so that we can reclassify the travelers to the 4 types of travelers that can match the types of travelers in the dataset of airline reviews. We have to make assumption that short-day stays, like less than 3 days, are often associated with business travel, while travelers tend to have brief focused trips with a quick return, while longer stays, more than 3 days or more, generally indicate a leisure travel, where individuals or groups have more time for sightseeing, relaxation, or vacation activities. So our first step is to analyze the relationship between these reclassified type of travelers and their preferences to better understand their background reasons for these complaints raised. So we can see from this table below that solo leisures have more preference in extra baggage and in-flight meals. However, business travelers show a relative average interest in all 3 kinds of preferences. And these results may indicate different concerns among different types of customers. Our second step is to define traveler types and to merge these two tables. In this step, you only focus on the customers who did not recommend the flight to analyze those complaints. And our third step is to find the number of complaints by the traveler type. From the table below, we can find that most of the complaints are raised by solo leisures and couple leisures, while business type of travelers raise the least number of complaints. Our first step is to analyze the average ratings for different aspects for complaints by traveler type. As we can see, the analysis of average ratings for complaints by traveler types reveals significant dissatisfaction among family leisure travelers, who have the lowest overall rating, 2.3636, and a notably poor perception of value for money. In contrast, business travelers exhibit higher satisfaction levels, particularly in staff services, and the solo leisure travelers enjoy the best experiences, especially in seat comfort and in-flight entertainment. And our last step for this is to identify the main cause of complaints for each traveler type. Here we define value for money issue, food and beverage issue, and value for staff issue and seat comfort issue, when the relative average rating is lower than 3.5. So here we can see the different type of travelers have different main complete causes for their complaints. Basically, solo leisure and family leisure travelers have the value for money issue for their complaints, while couple leisure and business leisure have more complaints about their food and beverage. This approach also has some limitations. For example, we can have some duplicated records because when merging these two tables, we only use the traveler type, which can cause duplicate records. If there are other homogeneous elements that can be derived from two tables, such as flight routes and some kind of like customer classes, I think the analysis can be more accurate. Also, when we rely on the defined traveler types, this may oversimplify the complexity of customer behavior. And because of the two tables are from two different airlines and time periods, our analysis can be lack of accuracy.
Okay, I'm Li Pengda from Group 1. So next I will introduce the approach 3 for the question 12. After the exploration of the two approaches mentioned above, we found that maybe it was too hard to merge the two tables, airline reviews and the customer booking together to reach various and precious conclusions. So this approach will focus on the text analysis of different types of travelers to reflect their concerning points based on the tremendous text data in the airlines reviews especially. So the first step is to create full text index. We used the syntax full text to process the text data first for keyword analysis. Later on in SQL Workbench, the syntax is just shown as the slides. And next step, we define several keywords that are related to complaint, including complaints, unhappy, disappointing, sad, angry. Once these words occur in the line of title or reviews under keywords matching against and query expansion. And this customer will be considered as who is not satisfied with this airline service. Besides, we also add more standards to refine this screening, such as recommended equals to no, overall ratings less than 6. After screening out these people based on all above standards, we use type of traveler, class, and route to analyze the possible type of travelers who complain more than others. Some results are just as follows. From above analysis, we can see that travelers of solo or couple leisure, economy or business class, departure from Australian cities tend to have a higher probability to complain. Next step, we try to explore the reasons behind. We changed the preliminary screening standards of overall rating to several specific factors, including seat comfort, staff service, food and beverages, in-flight entertainment, and value for money. To quantify our results, we set standards as lower than the average score of whole data sample. Results are just as follows. We can see that for economy class and business customers, value for money, in-flight entertainment, and staff service turn to be top reasons of complaining. For premium economy and first class customers, there are no obvious factors to bring them unhappiness. There are also some limitations about this approach. When doing the text analysis, it is hard to incorporate the customer booking table into consideration as its text content is so limited. Lack of merging two tables together also bring insufficiency data analysis problem caused by intrinsic lack of data source and methodology. Although we have drawn a number of conclusions from this approach, hopefully we may bring you enough findings from various perspectives based on the above three approaches. Thank you. That's all for our presentation.